In this tutorial, I'm going to show you how you can get the most out of modifying the lattice coordinate system to create new and different types of lattice structures. So to begin with, I'm just going to place a primitive cube into the center of our build plate. So I can go into geometry, click on primitive, and I'll set the size of this cube to be 50 millimeters in each of the axes and click create. So as we know, to create a lattice on an object, all we do is click on that object, click on the Lattice tab, and click on the lattice button in here. To modify the elements of the lattice, we're going to click on this problem components drop down and select the lattices button. Now, for this particular example, we're going to modify the lattice type and select the Schwarz P unit cell. We're going to want this to be a double skinned lattice, and we want the density to be about 0.35. Now at the moment, you can see by these crosshairs here that the coordinate system for this lattice is currently along the axes of the cube. So we would determine this to be a Cartesian coordinate system. Now I want to modify this to a cylindrical coordinate system. So to do that, I'm going to click Customize Origin, and this is going to add a node to the center of this part. Now when I click on this node, I get this Edit Coordinate tab come up, and this will allow me to change the position of this center point for the coordinate, but it will also allow me to modify the coordinate system. Now currently it's set to Cartesian, and I'm going to modify this and select cylindrical, and as you can see, these crosshairs have modified. We've now got a circular coordinate system in the center here, and I'm now going to go and modify these lattice parameters. So what I want is maybe 10 cells in the theta axis, the circular axis, 4 in R going out, and maybe 2 in Z. Now I can go into these generate settings, and I want to generate this at maybe, to begin with, a resolution of 0.2 millimeters, 200 microns. And we'll click generate and see what's produced. So we can see this has generated quite an interesting lattice, as we're putting a cylindrical coordinate system into a cube, or what we would normally think of as a Cartesian system. And again, if we want to explore the range of options in here, what we can do is modify the R value, number of cells, the Z value, or the theta value. So it could be interesting, for example, to add half a unit cell in and see what the difference in the shape of the lattice we produce. They're quite quick to generate, so we can explore quite a range of options. So again, now this is a vastly different look of this lattice, and we can begin exploring these different lattice types to try and produce what we want to achieve. As we can see from this lattice, where the center points of these converge, there can be quite thin walls in the middle of this part. So to overcome this, what we can do is add a cylindrical object in the middle and make this cylindrical object a solid. So we'll just press reset here and add a second primitive into the middle of this part. And we'll make this a cylinder, and we'll maybe make this 6 by 6, and then the height we can be 50. And we'll just select this cylinder model in here and set it to a solid. And now when we regenerate this part, we can see that this is now smoothed out. Now this might be a little big, so we can even go in and modify the size of this cylinder, but you can see from this that when we smooth it out, we will no longer have these challenging areas of small features in the middle of our lattice structure. So as always, when we're happy with the lattice that we've created, we can either smooth this and take some of these sharp edges out, or we can decimate the lattice and export this lattice out of the system as an STL file.